So today we are going to graph quadratic inequalities, and we are going to solve quadratic inequalities using algebra. So when you are graphing quadratic inequalities, you have to pay attention to what the sign is. And you might remember this from, well, I really hope you remember this from graphing linear equations. When we were graphing linear equations, we knew that we had a dashed line. Okay, so we have to pay attention to the signs. If it's greater than or less than, you are going to have a dashed line. If it is greater than equal to or less than equal to, it will be a solid line. Is that something you guys remember from the linear functions? The dashed line versus the solid line? Yep, so if it's equal to, it's going to equal those points. That's why the gaps have to be filled. If it's dashed, it is not equal to. So we use that to signify those are not solutions. So when you are trying to identify all the solutions for an inequality, there are very many of those solutions. So in addition to graphing the curve, we have to shade in the region where the solutions are true. Okay, those are going to represent all your possible solutions. And then you guys might remember we used a test point, or we can use different test points to decide whether we shade inside the parabola or outside the parabola. And that's going to change depending on the position of where the parabola is. Okay, so this is going to combine a few things that we already know how to do. So whenever you're graphing an inequality, we want to find the vertex first. Do we remember the equation we used to find the vertex? What is it? Close. Opposite of B over?
You didn't let me finish.
Okay. Over 2A. Okay, so opposite of B over 2A. Okay, so when you are doing that, I want you to put it in the middle of your chart, and then I want you to plug that into your graphing calculator. Okay, so I want you to find that x value, and then we're going to plug that into our graphing calculator. All right, let's see if we found that correctly. So when we do the opposite of B over 2A, we do 7 over 2 times 1, which is just 7 over 2. You can write this as 7 over 2 or 3.5. It honestly does not matter, but we're going to box it in and we're just going to label it as the vertex. Okay, and yes, we are going to find y, but we are going to use our chart to do that, our table, the graphing calculator. Okay, so in our y equals, we're going to type in x squared minus 7x plus 10. And then we are going to go to our table. Now my table set, I've been working with that today, so I'm just going to go into my table set, second window, start at 0, make sure it's going up by 1s. Okay, and then I'm going to go a few places up. So at 4, I'm at -2, because this is 3.5, so I'm going to go up to 4. At 5, I'm at 0. And let's see what happens at 6. At 6, I'm at 4. So that's going to be helpful. And then on the other side, I'm going to go 3, 2, 1 and see what happens there. And I know because parabolas are symmetric that if I have 4, 0, negative 2 on this side, it's going to go negative 2, 0, 4 on the other side. To find out what happens at 3.5, okay, one thing you can do is you can go to second table set. You could start at 3.5 and just see what that is. Or you can make your change in the table by halves, okay, and you can see what happens there. So we get negative 2.25 is what you get. You can always verify that by plugging it back in. And then based on this information, you are going to create your own graph here. Okay, so I have to make sure I go up to 4, but I also want to go down to negative 2.25 is the lowest value. So when I'm creating my grid, I might say, okay, I have to go at least 1, 2, 3. Okay, and then all of these are on the positive side, so I might make my y-axis so that it's mostly the positive values that I see here on x. And I can go by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I usually just label every few. And then we can plot those points. Now, before you plot the points, I do recommend, because this is an easy thing to mess up on, sometimes I mess up on this too, is the line solid or dashed? Okay, the line is going to be solid, and that's because you have the equal to. Okay, so if it is dashed, we're so used to making it solid that sometimes that can be something you want to double check. Okay, you also might want to use pencil in case you make a mistake with the points. Okay, so 3.5, and then it's negative 2, 2.25. So you're going to estimate about 1/4 of the way down. That is going to be an estimation. At 4, I'm at negative 2. At 5, I'm at 0. And see, I already made a mistake. Here I'm at negative 2. There we go. And then 5. And then at 6, I'm at 1, 2, 3, 4. All right, so I'm just going to check my points again. Negative 2.25. Here I'm at negative 2, 4, negative 2, 5, 0, 6, 4. Then I'm ready for this side. So at 3, I'm at negative 2. At 2, I'm at 0. At 1, I'm at 1, 2, 3, 4. Okay, and then one thing you might want to make note of is where your x-intercept is, or sorry, your y-intercept. So it's at 0, 10. So I'm at 6, 7, 8, 9, 10. So it is not going to cross this until I get here. So I just want this to be as accurate as possible. So I'm just going to draw that half so that I can draw it going to the correct spot there, right? It's not crossing that. And then I'm going to make this side symmetric. Oh, I don't like that part. Just going to erase that and make that look a little nicer. All right. And then once you have that, once you've done that in pencil, if you want to use like a highlighter so it stands out a little, that's fine. I have people that like to do that. Okay, and then from there, we are going to use our test point. So the test point, you can use 0, 0 as long as that's not a point on your parabola. So here's 0, 0. It's not on my parabola. when you are doing your test point, we are going to plug 0, 0 in for x and y. We're going to plug it into the original. So you have 0 squared minus 7 times 0 plus 10. When you are doing this and you are plugging in 0, 0, I am fine if you just do this, and then you have to tell me if it's true or false. So is 0 greater than or equal to 10? True or false? False. So we'll put a slash through it, and we'll write false. Anytime it's false, that means you do not shade 0, 0. Okay, so look where 0, 0 is located, because it's going to be in different places depending on where your parabola is. So if 0, 0 is outside and we're not going to shade it, for this case, we have to shade inside the parabola. You are not always going to shade inside if it's false. Okay, it's based on the situation. Okay, so we're going to do a nice shade here. Really let your art skills shine if you'd like to. Hopefully some. There we are. So we shaded inside. All right, and then once you've shaded that, I want you to start part B. So you know how to find the middle. So find the middle and then set up your graph. Make sure you're taking this time to practice and do it yourself. Don't just wait for me. Okay, so find the middle there. All right, let's double check how we did setting up the table. So I asked you guys to find your x value. So the opposite of b is 6 over 2 times negative 3. 6 divided by negative 6 is negative 1. So that's just going to go right in the center of your table. And then you can use your graphing calculator to look at those values. Okay, so we're putting that into y equals. You can go back and you can make your table set go by ones. That's the table set is above window. So second table set to make sure that's set up, and then second graph to look at your table. All right, so at negative 1, I'm at negative 4, and then at 0, I'm at negative 7, at 1, I'm at negative 16, and then when I get to 2, I'm at negative 31. Okay, so that is a little large. You could include that on your graph if you were doing it on graph paper, but based on this limited piece of graph paper I have here, let's just go ahead and graph until negative 16. Hey, you do want at least 5 points, so this is what we'll put on our graph. Okay, and we decided to do those 5 points instead of 7 like before, just because this is large. And when you are creating the axes, okay, just look and see what you have. So I want to go to negative 16, right? So I'm going to say, okay, negative 16. I'm going to have to go by 2's. So 16, 14, 12, 10, 8, 6, 4, 2, 0. So I can put this here. And just like I modeled for you when I was doing my counting, you can do something similar when you're doing this on graph paper. Okay, and then I told you I was going to have to go by 2's here, right? Negative 2, negative 4, negative 6, negative 8, 10, 12, 14, 16. In order to fit that on this limited space, obviously when you have your graph paper, you can make that as large as you want to. But if I look at my x values, I don't have to go by 2's. So as long as you're consistent and the y's are going by the same value and the x's are going by the same value, they don't have to be the exact same. So my x's, I'm just going to go by 1's. Okay, so x scale is 1, my y scale is 2, and now I'm ready to graph. And again, I'm going to do this with a pencil because sometimes mistakes happen. So negative 1, negative 2, 4, okay, because I'm going by 2's. 0, negative 7, so 2, 4, 6, 7. I know, whenever I count now, in my head, it's always 6 and 7. Okay, and then negative 2, 2, 4, 6. There we go. And then at 3, 2, 4, 6, 8, 10. Well, really, I just labeled it. Okay, so those should be symmetric there. And this is going to be dashed. So because you have a greater than, you need a dashed line. So make sure that you're thinking about that. That is something easy to forget. And so I'm going to make my dash through my points here. And then you just want to make sure you span your grid, whatever your grid happens to be. Because you don't want to, I think of this as like an umbrella, right? It has to cover either everything on the outside or everything on the inside. And you don't want to like go underneath it. Okay, so for step 3, you just identify what your test point is. If you can use 0, 0, I think that's the simplest, so that's why I use it. The only time you can't use 0, 0 is if one of your points is on it, and then you pick any point you want to. And then like I said for the first one, when you're plugging in 0, 0, okay, you know y is 0. We should also know that if we plug in 0 for x, this becomes 0 and this becomes 0. So you just have 0 is greater than negative 7. Okay, so you don't have to show me the plugging in step here if you're using 0, 0. But you do need to tell me if that's true or false. So is this true or false? True. Okay, so yes, 0 is greater than negative 7. If it is true, that means you shade 0, 0. And you have to look at the position. So in this case, 0, 0 is outside. Okay, so depending on where your parabola is, true might mean shade outside, true might mean shade inside. It just depends on where the point is. The point can be inside the parabola. It's just for both of these it wasn't. Okay, so it just depends on the case. If you want to add for this case here, you can. I just don't want you to think false always means inside, because it does not. Okay, it's dependent on the position. So because here it's true, I want to shade wherever 0, 0 is. 0, 0 lives outside this beautiful parabola with a dashed border. And so I tend to shade that first, and then here we'll shade outside here. Okay, and then just shade whatever grid you make. Do not shade underneath because it doesn't include any of these. All right, and that's all you have to do for your graphing. So that's really a combination of a few things that we've done before. All right, and then the other skill we're going to learn today is how to solve quadratic inequalities using algebra. So your book is going to say you can use a table, you can use a graph, you can use algebra. We are using algebra. That is the only thing you will be quizzed on, okay? So the first thing you want to do is move all terms to one side. Okay, and like I warned you before, factoring is never going away, so we are going to factor today. Okay, then we're going to find the critical values. If you find yourself getting stuck, come back to this list. I made it for you so that you could look and see what you have to do. What's a critical value? Where each factor equals 0. And then we're going to express them as inequalities. And we're going to do that on the number line. I'm going to help you with this. Okay, so we're going to express as inequalities on a number line. Okay, then we're going to make a table, we're going to make a chart, and when we do that, we're going to pick some test points in these intervals, and we're going to determine if it's a true or a false statement. So we're going to make a table, we're going to determine if it's true or false, and then we are going to write our solution, which is going to be wherever the test points are true. Okay, the solution is going to be an interval or intervals. So I'm going to put S in parentheses. It could be one interval, it could be multiple intervals. Okay, and I called this example mixed exercises because I want it to line up with what your book says. So your book calls these mixed exercises, okay? So the directions in your book look like this. It says, solve each quadratic inequality by using a graph. No, we're not going to do that. By using a table. No, but technically we kind of are. Or algebraically. Yes. Okay, so you are going to be doing the algebra method. Okay? And we are, it says we are solving these using algebraically. We really either say using algebra or we gotta omit the using. We are solving these algebraically. Okay? And then this is how it'll be on your homework and quiz. Your homework and quiz will say using algebra. Okay? All right. So, yeah. It's almost like people don't follow directions. So I need to tell them that this is what we got to do. That's what it'll say in your quiz. So the first thing we're going to do, we're just going to follow all these steps. So step 1, move everything to one side. Well, they were very nice and they already did that for us. So when you move terms to one side, that means the other side should be equals to 0. Other side is 0. So that's already done. Okay, if you have 0, then we're good. All right, then step 2, we are going to factor. So we are looking for values that first are going to multiply to x squared. So we know how to do that. You can confidently put in that x and that x, and then it has to multiply to -2. The last two, only things that multiply to -2 are either 1 and -2 or -1 and +2. So if it has to add the -1, which one's negative, the 2 or the 1? The 2. So -2 plus 1. And what you should be doing is you should be doing this check either in your head or on paper. Okay, if it's in your head, that's fine. Just saying, okay, that's negative x, yes, that's what I want. Okay? All right, and then we're going to go to step 3, which are the critical values. So critical values are where each factor equals 0. So the first factor is x minus 2. We're going to set that equal to 0. The second factor is x plus 1. We're going to set that equal to 0. So if I add 2 to both sides, I get x equals 2. If I subtract 1 from both sides, I get x equals negative 1. Okay, so these are my critical values. Do you guys have any questions on steps 1 through 3? Steps 1 through 3 really are reviewed from what we did with solving with factoring. Okay, step 4 is where it's going to be a little different for your table. Okay, when you are making the table, the intervals are created by setting up a number line. And I'm actually going to draw it up here because I just want you to have some space to look at this, okay? So when you are setting up your critical values on your number line, they have to go in numerical order. So negative 1 goes first, 2 goes second, and your intervals are created from these values. So the first interval goes from negative 1 to the left. The way that we would say that is that x is less than negative 1. Okay, so what I've highlighted in green here, okay, this value would start at negative 1 and go all the way to the left. Okay, that would be x is less than negative 1. Okay, that's what we're going to put in our chart here. X is less than negative 1. That's the first interval. I'm going to show you a quick way to do it. So yeah, fill out this chart with me. Okay, and then this middle region is from negative 1 to 2. So these are going to be your bounds. So negative 1 is less than x, which is less than 2, is going to be your middle interval. If you know the last one, feel free to write it down, but don't say it out loud because I just want to give everybody enough processing time. I know you guys are processing things at different times. That's okay. Okay, and then the last interval is all the values that are greater than 2, so it's going to be x is greater than 2. And you may be wondering, well, how did you know that it was just greater than and less than and there was no equal to? That is going to be based on the original equation. So if there's no equal to, you aren't going to include it in these. If there is, then you will. Okay, any questions for how I got the intervals? The less than, the greater than, the in between. All right, then we're going to pick a test point in each interval. So all you need to do is pick a number in the interval. So for your test point, you're going to pick a number in each interval that is not a critical value. So it can't be negative 1 and it can't be 2. Okay, it really wouldn't be anyway for this, but if it was equal to, you need to know that you can't pick the critical value. Okay, so you're going to pick a number in each interval, and we're going to write it down in our chart. Now this is something that you'll be required to do without a calculator, so let's pick numbers that are going to be simple for us to compute without one. So the first one says x is less than negative 1. What's the value that's less than negative 1? Yep, you could do negative 3, you could do, what else? Negative 5. You could do negative 2, which is what I chose. You can choose anything less than -1. Okay, and then from the second interval, -1 to 2. What are some numbers in between there we could choose? 0 or 1. Okay, I always think 0 is going to be the simplest to compute, so that's what I would choose. And then if x is larger than 2, what's the first number larger than 2? 3. All right, now I want you guys to plug these into the original equation. This is a really good time to practice those mental math skills to see if we can do this. So when you're substituting this in, it's -2 squared minus -2 minus 2. Okay, so I want you to evaluate that. And then I want you to plug in 0, find that, plug in 3, find that inequality. Okay, so we're doing that without our calculator. All right, let's see how the first one went. So -2 squared is 4. A negative times a negative is a positive. Okay, 4 plus 2 is 6. 6 minus 2 is 4. Okay, so your inequality is 4 is less than 0. Is that true or false? False. Okay, when you plug in 0 with 0, remember we talked about these are going to cancel, so it's just -2 is less than 0. Is that true or false? Is -2 less than 0? Yes, it is. Okay, and then here you have 3 squared minus 3 minus 2. Okay, so 9 minus 5, which is 4. That's exactly what we have there. That does not happen all the time. Okay, but that is false. So your solution is going to be whatever is true. So the interval that is true is -1 to 2. What that means is if you plug in any number from -1 up to 2, you are going to have a true statement for that original equation. Okay, if it's not in that interval, it will not be true. Okay, so I understand writing this chart out on your homework over and over again would be unnecessary torture. So I'm going to show you a quick way to do that, okay? So the first thing we're going to do is make sure that all the terms are on one side. So that means I'm going to have to subtract the 1 over. And then you guys are going to do what you do best, which is factor. So I want you to factor, and then we're going to find those critical values, and then I'm going to help you set up the next step, okay? So I want you to take a moment and factor that. Think about what can you multiply to get to the first. All right, so the only thing that multiplies to 2x squared is 2x and x. only thing that multiplies to -1 is 1 and -1. So we just have to make sure we position those in the right places. So if I put a +1 here and a -1 here, if I check that with FOIL, I have -1x and I have 2x, which will be positive x. That's what I want in the middle. So to find the critical values, I'm just going to set each factor equal to 0 and I'm going to solve. Okay, so we factor, we find these critical values, so I'm going to add over 1, I'm going to divide by 2. My first critical value is 1/2. My second critical value is going to be -1. So I'm going to show you how you can set up your number line to be a chart. So what you want to do is put these in the right order. If you do not put them in the right order, you're not going to get the correct answer. So -1 comes first because it's the lower number, then 1/2. Okay, and then I'll do the first interval for you, and then I'm going to challenge you to write out what your other intervals are. Okay, so the first one is x is less than or equal to -1. You have the equal to because of the original function. So see if you can set up the next two. Yourself some room. I made that really large for a reason. All right, so then in the middle, we should have -1 is less than or equal to x, which is less than or equal to 1/2, and x is greater than or equal to 1/2. Okay, so these are your intervals. Here, we're going to put our test points, and we're just going to make this like part of our chart. Okay? All right, so I want you to choose your test points. Pick a number that's less than or equal to -1. Pick a number that's in between -1 and 1/2. Okay, so what's a number that's less than -1? -2. It can't be -1 because it can't be a critical value. What do we choose for -1 and 1/2? 0. That would be the best one. And then greater than 1/2, 1. So then you are plugging them in to, I would choose this equation. Okay, you can decide what equation you're using. You could use this one or you could use the original. They're both going to give you the proper values. Okay, but I'm going to use the one where it's greater than or equal to 0. Okay, so it's 2, -2 squared plus -2 minus 1, and that's greater than or equal to 0. Okay, so I'm going to give you a moment to practice that algebra. A lot of times when people are making mistakes on some of our assessments, there's small order of operations. So I want to give you a chance to practice them here, make sure we know how to work those. All right, so You have to do the exponent before you multiply. So negative 2 squared is 4. 2 times 4 is 8. Negative 2 minus 1 is negative 3. So you should have 5 is greater than or equal to 0. And then you're going to tell me if that's true or false. So this is true. So it's like we're making the same chart, but just a different direction. When you plug in 0, I told you that if you know this is 0 and this is 0, okay, this is enough for me. Negative 1 is greater than or equal to 0, which of course is false. Okay, and then for this one, we plugged in 1. So 2, 1 squared, plus 1 minus 1 is greater than or equal to 0. 1 squared is 1. 1 times 2 is 2. 1 minus 1 is going to cancel out, so you get 2 is greater than or equal to 0, which is a true statement. So when you have two values that are true, you are going to have two intervals that are your solution. Okay, the way that you are going to write that is that x is less than or equal to negative 1, or x is greater than or equal to 1/2. You need the or because there is no value that's going to be both of those. Okay, so you can't have a value that's less than or equal to negative 1 and greater than 1/2. Okay, and then so your homework for tonight, because you have a quiz on Thursday, I really recommend that you do this practice. Okay, this is going to be like your first A grade in the new term, that quiz, and so when you have time to work in class, I want you submitting your homework even if you didn't finish the whole thing, okay? But if you finish everything, I'm going to give you your points for that. So if you're somebody in quarter one, if you're not where you want to be, don't leave any of these points on the table. Okay? With a lot of the textbook homework, I don't penalize you if you can't get it done, but I do reward you if you do get it done. And honestly, you reward yourself. Okay? People that are turning in all their homework are doing really well in their assessments. Okay?